I've already drilled the first one, and now I'm ready for the second one, and then I'll do the third one off camera, and it will help a great deal if you have a wooden block under there rather than just drilling into this hole. But if you do, be careful you don't drill into the table. But a sacrificial piece of wood, this being maple, is even better, and you can see the black line. I think you can. And get a good grip on the work. And now if you're unsure of this or scared, then make sure you do clamp it down. And you don't really need any lubricant. It doesn't tend to grab. I used to think these bits were a novelty, but they are not a novelty. They are great. See what a fine hole that produces? And again, a burr on the back side, and I will just gently drill from this side, and that'll take that burr off. You get yourself one of those bits if you like, but get a high quality one. Don't get the cheap one, and they don't come cheap. I think those are about $22. That's what it looks like so far, and I'd say there's about a half hour's worth of work in here so far, and I've removed the burr from the back side using this. Now this is a self-piercing bit, but I prefer to pre-drill, but you can see that will self-start. And the brand name on this is Unibit. It's called Unibit, so that's the company's name. I think Greenfield makes one too. Probably a lot of companies make them, but make sure you get one made out of high-speed steel. Now the next thing I'm going to do, and it'll be off camera, is I'm going to finish the sawing. So I'll saw along here and around here. I don't have a very narrow blade, so I have to make a series of cuts, and then I'll sand it to the line. Along here, here, and here. Again, be careful that you distinguish between the saw lines and the fold lines, so you do not spoil the work. Some of you may not have a bandsaw, so you're going to have to use a hacksaw, but make sure you use a brand new blade and a fine tooth blade, and possibly sandwich this between two boards so you do not bend it, because this is relatively soft material. And once you bend it, you really won't get it back very straight. But I'll just take a couple sample cuts here where I'm going to cut across here and then down there. That's all I'll show. But always staying a little bit on the outside of the line and allowing for the kerf. You might use a block to push it. Doesn't cut very straight. Now at this point there's considerable handwork. I'm going to do the belt sanding as much as I can around here, but in some places you can't swing it fully around, or you need to finish it from this side, but there'll be no layout lines on that side, and there'll be filing. For instance, in here I can't use a belt sander at all, so I'll have to file that to the line. And a lot of you won't have a belt sander, but if you have one of those little narrow belt sanders, it might be just the thing for getting in some of these tight spots. But you want it to look as good as you can before you make your bends, because it's most difficult to hold and probably impossible to belt sand after you've made the bends. So this is how I do it. I'll just show a little bit of it. Taking it right down through the line. For the areas that you can't get in with your belt sander, or if you don't have a belt sander, make sure you hold it in the vise and with jaw protectors, and always have the layout line very close to the vise itself so that you don't bend it over. For instance, you wouldn't want to file up here. It's going to squeak on you too, but that's going to bend, or that's going to bend. And be careful that you don't file into the corners here and take out the radius and end up with an unsightly corner. But this is really the only part that I have to file by hand on mine, because I got all kinds of equipment, but many of you will not. So use a fine file and a sharp one if you got it. Well, there it is. All the filing and sanding is pretty much done for the moment, and I'm ready to fold it. Now I have a little brake that I'm going to use. If you know somebody that has a brake, or you know of a shop that'll break that for you, it would be nice, because it's not that easy to do in the bench vise, but probably most of you are going to have to do it that way. But you also have to allow for the thickness of the material, which is called a bend allowance. Or after you fold it up, and this may even happen to me to some extent, what will happen is that one side may end up slightly higher than the other side. Now that won't make any difference down here, but in this area, if one side is a little bit higher, you might want to file it down so that they become even. And that's why we didn't drill the hole for the main bearing yet. And that'll be even more obvious here in just a little while. Or you can use my drill a little hole method for making your bend, and then probably make those holes even a little bit closer than what I show you there, and maybe run some practice pieces and rehearsals on some scrap like I did on this several weeks ago. I drilled some holes. You can see it pretty much bent right on there, but those holes aren't close enough together. Those are 16th inch holes. So then I did another one. Now those weren't laid out, so it's kind of baguesse and bagosh on that, but you get the idea of you want the bend to occur on your line, not just any old place. Now I'll take you out in the garage and show you how I'm going to bend mine on the little brake that I have. It was a bit dark out in the garage, so I brought the brake or the bender down into the basement shop where the lighting is better. And if you've never used a brake, you know, this is a simple one. It's a cheap one. It's probably considered a hobby model, but it came from a garage sale. I do not have a heavy-duty one. But all a brake does is to hold the sheet metal down, and the layout line will go right against the jaws. Some of them have removable jaws, like that. And in this particular case, it clamps down like this on both ends. And once you get it clamped, then I'm going to work toward the middle. And I probably will put a C-clamp back here because this entire bar here seems to bend. But then after clamping the work right on the layout line, you just bring that up to 90 degrees. And the bend is made. And then reverse it like this for the other bend. The workpiece is clamped down tightly right on the line, and I put a C-clamp back there for the reason I just told you. So all I have to do now is lift up on the handles, and I probably have to go just a little bit over 90 degrees to allow for what we call spring back, but there probably won't be as much spring back on brass because it's soft as there would be on steel. So here we go. And I'm going to check it for squareness. Got a little farther to go. That looks pretty square, and I'll take it out. And there's the first bend, and now I'll put it in like this for the second one. And here I go for the second side, right on the line. Notice how I lined up the C-clamp so it would come right in here and give me clearance. I don't want to overbend, so I'll take it out check it with a square and see if I need to put it back in. Actually, it's pretty darn close, possibly just a little bit of an overbend there. The first side is virtually right on, so I'll back this off just a little bit if I can. Now, if you do not have a brake, there's also the possibility of taking a piece of maple that's the correct size right in here and have a couple screws through here to hold it into the maple, and then make your bends, probably by hand or with another board. So I want it to be pretty much like a U, the sides at 90 degrees, and it even looks like I got these two sides pretty close to the same height, which is sometimes hard to do. Now if you misbent it, you're never going to be able to straighten it out. Don't even think about it. But if one side is higher than the other, you could file it down so they're the same. Or to some extent, if it's a minimum amount, it isn't even going to show up once you get the flywheel on there. But there, the bends are made, and I probably should have drilled a couple mounting holes in there ahead of time, and I think I'll do that next. And those are the holes that hold it down to the wooden base. And those should be drilled such it won't interfere with the main shaft here with your screwdriver, or you can see we got a little bit of a problem here where the screwdriver can't come in straight. So I did correct that. That's the value of a working drawing, so that you don't have interferences, and I generally don't work from a drawing. And that probably is one of my shortcomings, but that's just the way I do it. But that's how the bend is made, and I'll set the brake aside for now. I drilled the mounting holes. They're just 1/8 inch holes, and they're about 3/8 to a 1/2 inch from the end. They're not the same because I want, well, I'm not going to give you the reason, but it isn't very critical. Also notice that I ended up with a mirror image of this, so the cylinder will be on the other side, which is just fine. But if you want the cylinder on this side, you need to bend the other way, but that's where my layout lines were, so that's going to be fine. And then looking at it this way again, on the surface plate, if I put the little die maker square on there, it's pretty darn square. Just what I want. Well, old TUBALCAIN's tired and he's going to go upstairs and eat, and then continue on this tomorrow. And don't work at late hours if you're not up to it, and never do any of this precision work if you're drinking, and I don't have to worry about dope because TUBALCAIN does not have any viewers who take dope. See you tomorrow. Good morning, and it's day 2 of the Yellow Boy little engine build. And before I get started here, let me talk just a little bit about copper alloys. And I build this material here as brass, but in fact I don't even know if it's brass. It may be bronze, and these two alloys really cross over. They're not clearly defined, but brass is generally thought of as an alloy consisting of copper and zinc, and that's going to vary in the proportions, but generally in the area of about 2/3 copper and 1/3 zinc. But there may be other alloys in there, other materials as well. It could be lead in there, and whatever it is that they want to accomplish with that alloy, depending on what they're going to make. And bronze, which typically would be bronze statues and things like that, is made of copper and tin, but then again there are other materials in that as well. So since this is not really clearly defined, often we refer to brass and bronze as copper alloys. And there are many others in there besides the brass and bronze, but so to confuse the issue even more, you know, I don't really know what we got here, but brass tends to be more yellowish in color like this than what does bronze. So that's why when you compare the two, there is a possibility that this is bronze, but I'll never know for sure unless there was a chemical analysis. And of course this is probably pretty much pure copper here, but I do not know that for sure. And a penny is no longer copper. That's actually zinc that is copper plated. So otherwise the value of a penny exceeds a penny. So they had to water it down with other materials. But that's what copper alloys are, and that's pretty much the difference between brass and bronze. And I don't know if that cleared it up at all, but there is a difference, but it doesn't make one bit of difference for what we're doing here today on these little engines. Back to measuring the thickness of sheet metals, there are 3, 4, maybe even 5 different gauges that can be used, and if you use the wrong gauge, of course you're not going to know what the actual thickness is. And a gauge can be a measuring tool, like these are gauges, and with them we are determining the thickness of a metal, and that also is called a gauge, so the word is used both ways. But this little one here, for instance, is for piano wire or music wire. It has no real use for what we're doing here, but I just want to tell you that there are different types of gauges, and more than what I have here. I don't own them all, but this particular one is called United States Standard Gauge, and that's for sheet and plate, iron and steel. That is not to be used on non-ferrous metals. Non-ferrous, for you young guys out there, are metals that do not contain let me rephrase that. Ferrous metals contain iron, so that would be steel and iron. Non-ferrous do not contain iron, and that would be brass, copper, aluminum, zinc, and so on. Anyway, using the United States Standard Gauge, and this is sheet metal, this is steel. You can see a little rust on it, unplated, and you would just go around the gauge until you found the one that it fit in. But you don't have to force it in. Now if it's plated and it's galvanized or something, you have to allow for that thickness. So that's the United States standard, but we're not really concerned with that one today. I'm just showing you the difference. This is the one that would be used, and it's called the American Standard Wire Gauge. These are both Starrett, and that would be used for non-ferrous metals, and it can also be used for wire. So in other words, an electrician would use this. Here's a piece of 14 gauge wire out of Romex, and you can see that it fits into the 14 slot. This material that we're using on the Yellow Boy, I told you it was 45 thousandths thick, and yesterday I didn't know what a thickness that was, but with this gauge it is a 17 gauge. And we would use that, of course, on brass, copper, and aluminum. So if you were to order metal, now you can look this up in books and charts and so on, and determine what you want to get. And notice that on these gauges that the backside would tell you the corresponding thickness in thousandths. So it's thousandths on one side and the gauge on the other, and that goes for this one as well. This one's a little tarnished and hard to read. And these are precision gauges and need to be treated with care. But I guess that's enough here on talking about the thickness of ferrous and non-ferrous metals. Now on with the build. If you own a surface plate, work off of the surface plate is so much more accurate than just a bench top, but make sure it's clean. Some of you have maybe never heard of a bench or a surface plate, but this one made of black granite, but they come out of iron, and they aren't very expensive really, but they're just a super accurate, level, true surface. Now I talked yesterday about the holes here for the main bearing. And sometimes I drill just one here, and then I drill all the way through, so I have the other one in line with the first one. If you have pre-drilled those and then folded them, I guarantee they're not going to line up, and your shaft will not be level this way. It's going to be cockeyed. That's why I held off on this. Now if you're working from a drawing, go ahead and lay this out either with a combination square or a height gauge, to determine the location of one or both of those holes. But since I've already laid that out, but my layout is on the inside, so I'm going to transfer those measurements to the outside, and I like to do it on the surface plate using an angle plate and a height gauge like this. Always hold it square up against something, and I've taken that measurement off the inside here, used a little flashlight so it was accurate, and then I'm going to mark them like this. And I'm going to do that on both sides. But it's important that the work be perpendicular when you do that. Now, if you do not have a height gauge like this, you can also use your surface gauge. But this is not direct reading. You have to use this by transferring measurements or taking a measurement off of a ruler. I prefer, of course, this, but they cost more. So this is a height gauge, this is a surface gauge. They are not the same. Sometimes I misuse the words, but now I will do the same thing for the height this way. So off camera, I'll pick up that dimension from the inside there, and then I'm going to bring it around and scribe on the outside as far as this height is concerned. This measurement is about 1 1/4 inches up from the bottom, but actually on the original one it would be 1 1/4 inches up from this surface here. But it really isn't that critical, but I transferred the measurements, so mine is a little bit different than the 1 1/4, but describe it like that and that. Now notice I got a little bit of a wobble there, so I'm holding it level, and I'm also marking it right here, and you'll see why in a little while, because we want the center of the cylinder to be located on the same plane or distance as the main bearing. Now when you use your surface or your height gauge, this is a carbide scriber, so sometimes I like to scribe it deep enough so there's actually a little bit of a furrow there, because then when you center punch it, the punch actually can ride in the furrow for accurate location. So I'm going over those one more time.